All right, we are starting a brand new unit.
Are we gonna go over our test?
We are not.
Okay.
Activity 19. We are doing arithmetic sequences and series. Sequences today, series tomorrow. You'll know what those mean by the end of today and tomorrow. Then we'll get into what we call geometric sequences and series. There's definitely a difference between arithmetic sequences and series and geometric sequences and series. I would argue arithmetic is a lot easier, which is why they start with them. This word, it looks like it would be arithmetic, but the way we phrase it when we're talking sequences and series is we say arithmetic. It's just the way we do it. So let's get started. There's some vocabulary here that deals with science. Don't worry, you don't have to really know science to understand it. They're just using a word problem, and it happens to be about science. But you'll be able to figure it out because there's a table. So here we go. First paragraph on 295. Hydrocarbons are the simplest organic compound containing only carbon and hydrogen atoms. Hydrocarbons that contain only one pair of electrons between the two atoms are called alkanes. Alkanes are valuable as clean fuels because they burn to form water and carbon dioxide. The number of carbon and hydrogen atoms in a molecule of the first 6 alkanes is shown in the table below. Have we heard of these words in science before? Okay. Well, either way, there's a table, so we don't have to know too much about it. Number 1 has 3 parts. We're going to break it down to one at a time. Number 1, graph the data in the table. So the table is hydrocarbons. We will call that X. They're going to actually call it N. And then hydrocarbons is like your output Y, but in function form, it's like F of N. So you have some graph paper on the side, like always. Let's not do this. That would not be very smart. We don't have negative X's or Y's, so we don't need any of those quadrants. We only need the first quadrant. So your graph should look like this in the margin. Go ahead and plot these inputs with these outputs. Don't forget to label your axes. That's always a good habit because we forget and we miss points on a quiz. If you had to describe this graph in one word, how would you describe it? Linear, yeah. Good news for you guys. Arithmetic sequences are always going to be linear. So you have a lot of experience with this kind of stuff. The things we do today, the patterns we do, the vocabulary we talk about, will carry over to geometric sequences and series, which are not linear. So don't say, I know how to do linear, and just don't pay attention. Because some of the things we're doing are going to translate to geometric sequences and series. So, number 1, it says graph the table. We got that done. Write a formula, F of N, to describe this. I'll give you some time. Go ahead and write your formula for that information. If you already have one and you're still thinking. Yeah, you have one? Yeah.
Yeah.
Yeah. Okay. Now this table was set up really nicely for us to come up with that. Let's talk about if it wasn't set up nicely. Like if you're given maybe this point and this point, or numbers in the hundred, we need to know how to write an equation. So we've done this before, y equals mx plus b. Your m is your slope. So slope is always y minus y. Any y's you want in any order. Once you pick the order, y minus y, you have to do x minus x. So that's 12. Oh, sorry, that's 2 over 1, so a slope of 2. The intercept is when x is 0. So you could count backwards, but we don't really want you doing that because if I give you the 50th point, that's a lot of work. So a good idea would be to pick a point, let's say 6, 14. The y is 14. We already know the slope. The x is 6. The only thing that I don't know is the thing I want, the y-intercept. So that's a good way to find it if your table wasn't so easy. Describe the domain of the function. We can leave that blank. We know what the domain is. They're always going to be whole numbers because we have carbon atoms. We don't have a half of an atom. So we're always doing whole numbers. Let me read the next paragraph. Any function where the domain is a set of positive consecutive integers forms a sequence. Consecutive means after the other, we're not skipping any. The values in the range of the function are the terms of the sequence. When naming a term in a sequence, subscripts, do we know what subscripts are? Good. Subscripts are used rather than traditional function notation. For example, the first term in a sequence would be called a sub 1 other than f of 1. So normally if we were looking at this table and I said, what's f of 3? You would say, okay, if I input a 3, I get 8. F of 3 is 8. When we're talking sequences in series, it's normally written like this. A sub 3, no difference. You just need to know that that's the notation we use. So let's consider this sequence. 4, 6, 8, 10, 12, 14. That's the sequence we're using. Number 2, what is a sub 1? And what is a sub 3? Don't make it difficult. It's just like if I said, what's f of 1? What do I get in the first term? And I get that. First term is 4. Third term is 8. That's it. Number 3, find the differences. I'll do a couple of them with you. First, they want us to find the difference from the second term. Subtract the first term. That's a difference of 2. The difference of a sub 3 minus a sub 2. Keep going. Find the differences they ask you for. Hopefully you noticed something. The difference every time is 2, just like our slope was in our first equation. We will call that difference, go ahead and put 2 equals d. The phrase we use is not slope when we're dealing with sequences in series. We're calling it d, the common difference. It says sequences like the one above are called arithmetic sequence. An arithmetic sequence is a sequence in which the difference of consecutive terms is constant. That's pretty much the definition of linear. Maybe write that down. Always going to have a common difference. That constant difference is called a common difference and is usually represented by D, common difference. Just so you're aware, you can have a negative common difference. So instead of adding the same thing, I could subtract 3, subtract 3, subtract 3. My common difference is negative 3. You can add the same thing or subtract the same thing, and it's still linear, which is an arithmetic sequence. Flip the page. Use a sub n and a sub n plus 1 to write a general expression, I would say equation, for the common difference. I'll give you a second to think about that. I need to use these two pieces to write an equation. If you're stuck, look back. We just did the common difference 1, 2, 3, 4, 5 times. We kept subtracting 2 things. These were specifically the 6th term minus the 5th term or whatever specific thing they asked you for. This one is just general, a sub n, so a random term. So if I did this, would that work? The term minus the term after it. No, I need those in the opposite order. The difference is subtract the term before it. A sub n is the term before a sub n plus 1. Kind of new notation for you. Please read 6 through 8 and do those on your own. If it has a common difference, the answer is yes. Number 6, plus 5, plus 5, plus 5, plus 5. Every time it's plus 5. So yes, and then it says state the common difference. D equals 5. Number 7, plus 1, plus 2. I don't even have to go any farther. It's not always the same. I have 2 different numbers. So no, this is not an arithmetic sequence. 8, find the missing term in the arithmetic sequence. So I know for sure because it tells me it's arithmetic. So I'm adding 9, so I better add 9 again. Add 9 again. That one's already given. 64. Anybody do that without a calculator? Very good. All right, number 9. Write a formula for a sub n plus 1. So how do I find the next term? I take the term before it and do what with it? What? Plus So like if I have this one, 46. How do I get the next term? I take the term before it and I do what to it? I want this term, that's the 1, 2, 3, 4, 5, 6 term. If I want the 6th term, I take the 5th term, the term before it. Oops, I don't know why I wrote, well, I was going to write this. I take the term before it and what to 55? Yeah, I add the difference. So that's how I want you to write that formula. Any term that I want, I would take the term before it and add the difference to it. Put a box around this, maybe a star. You don't want to lose this. It's not as important as the next formula we're going to write, but it's somewhat a tiny bit important. This is called, maybe this isn't how I want it written. Yeah, that'll work. Next to this one, I want you to write the word recursive. And a sad face. Why a sad face? Well, if I want the 50th term, I have to know the 49th term. And I might not know that. So that's a pain. This formula is not really that helpful unless I'm given the term before it and the difference, which usually doesn't happen. So we're going to come up with a better formula today. It's going to have a different name, and we'll put a bigger box around that one. Let me read the paragraphs there that fall under number 10. Finding the value of a sub n plus 1 in the formula you wrote number 9 requires knowing the value of the previous term. Such a formula is called recursive formula, which is used to determine a term of a sequence using one or more of the previous terms. That's why I don't like it. You have to know the term before it, and you don't always know that. Next paragraph. The terms in an arithmetic sequence can also be written as the sum of the first term and a multiple of the common difference. Such a formula is called an explicit formula. We like those. Put a smiley face by the word explicit. Recursive, that's a no-go. So these new ones are called an explicit formula because it can be used to calculate any term in the sequence as long as the first term is known. So let's come up with how we write better formulas that don't require the term before it. Let's look at this pattern in number 11. We have the sequence 4, 6, 8, 10, 12, 14. A sub 1, or the first term fill in is 4. Our common difference plus 2 plus 2 plus 2, so our common difference is 2. Now, if I want the second term, I take the first term and I add this difference how many times? I just want the next term, so I just add it one time. I've got the first term, I'm just getting ready for the very next term. If I want the third term, I've got the first, it was 4. I added the difference here. Now I'm going to add the difference again. I'm going to add the difference twice. If I want the fourth term, I know the first term. I'm going to add the difference to get the second. I'm going to add the difference to get the third. I'm going to add the difference again to get the fourth. So I've added the difference 3 times. Fill in the rest of those. Be careful because it kind of jumps there at the bottom. James, what number goes in this blank here? Ooh, it jumped. We want the 10th term. If I want the 5th term, I add the difference 4 times. If I want the 6th term, I add the difference 5 times. So it'd have to be 1 less. For every term, whatever it is, a sub 3, I add the difference 2 times. A sub 4, I added the difference 1 less time because I didn't have to do it to get the first term. So we can calculate that. 9 times 2 is 18. 19, 21, 22. This is a formula for specifically this sequence. We're going to use the patterns described here to write a generic formula. This is going to be very important. Our most favorite formula for the day. You can write it wherever you want. It technically goes under number 12, but anywhere is fine. We're going to write a generic formula that works every time, not just for this sequence. So let's take a look. Every time we started with 4. Does every sequence in the world start with 4? What does 4 represent in this problem? What? Say it louder. Ace of 1. Yeah, your first term. So right. Ace of 1. Then every term we added, which we are going to do again. And the number we added to that kept changing. We added 1, then 2, then 3, then 4, 5, then we got to 9. How do I determine how many I'm going to add for the difference?
N minus 1.
Very good. Whatever n is, so here n was 10. We did 1 less than that. So we're going to write, we're going to add n minus 1 times, we multiplied by 2. Do we always multiply by 2 for arithmetic? 2 represents common D, difference. Put a smiley face by it. What kind of equation do we call this? Explicit. Maybe write that also. Highlight it in your book. Do we understand the reason for the smiley face and the frown face? Smiley face means we like it because I can now find the 50th term without having to know the 49th or the 35th or any term. The sad face was recursive. I had to know what came before it. Go ahead and read number 16 and try those on your own. You're using the formula you just had. I'm going to use my formula. The first term they tell me was 6. N is 40. I want 1 less than that, so 39. And my difference is 3. $123 is my answer. Go ahead and try B. we go. First term is given 37. 1 less than 30 is 29, and you just have to calculate the difference instead of them telling you. Pretty easy. Any questions so far? What does it mean to be an arithmetic sequence? What has to happen? Has to have a common difference. Then we need to know the difference between explicit and recursive. Which one do we like better? Explicit. Recursive is just the term before it plus the difference. Go ahead and try A, B, and C at the bottom of 297. I'll do them up here. Just look up if you need help. Yes.
I'm not just slow.
Well, this isn't your y-intercept. That's the first term, not the zero term.
But like, isn't it just?
With the n minus 1, sort of, but it's not exactly slope-intercept. It's not your intercept. Any questions on A or B? What I told the last class was, and I know, well, I shouldn't say no. I haven't seen anybody do this yet, but if we are in our calculator doing 19 plus 4, 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 till we do that 28 times, that's not good. If I see we're doing that and not doing this process or the algebra behind the process, then you're going to force me to put numbers like this on your test so that you can't do that by hand or you won't finish your quiz. Understand? So we shouldn't just be doing plus 4, plus 4, plus 4. Do the algebra to get to that term. All right, which term in the sequence is equal to 72? Well, let's start with what we know. Here's a good formula or place to start. I do know the first term is 15. I don't know what n is. I'm trying to figure out what term I'm at. I know the difference. We're adding 3 each time. I would like this equation to come out to equal 72. So pretty easy setup if you have the equation. Lots of ways to solve this algebraically. I'm going to subtract first. Divide by 3. And add 1. So the 20th term. So again, we wouldn't want people just 24 plus 3 plus 3 plus 3 plus 3 plus 3. So you get to 72 and count them out. So show a little bit of work so I know you're doing the math.
Would you like that? Like, is it n equals 25? Like, you must put a of 20.
Yeah, that's fine. Yeah, which term? You could just say the 20th term or n is 20 is fine. Alrighty, flip the page. We're going to look at 18 and 19. I'm going to give you some time. I think you can do 18 on your own, and 19 goes with 18. So again, do those on your own. Look up if you need to. Any questions on 18 or 19? Alrighty. There's your homework.
I'm sorry, what was the answer?
That's okay. N is 8, so the 8th term or negative 3.5 was 18. I can come look at it, or you can retype it in and see what happened.